Okay, this is question number 5, January 2022. As we can see, it's an equilibrium question. They've given me the situation where they've given me tan alpha equals 3/4. I know I've got that the particle is going to be on the point of sliding up the plane for my first bit, so let's get on with it and get started. This diagram isn't good enough, I don't think, for me to draw all over, so I'm going to draw a new diagram out, put all my information on it. So what have we got? We've got a particle acting on a plane. We know the angle alpha there, where tan alpha equals 3/4, and straight away I'm going to say what sine alpha and cos alpha are going to be based on that fact, and this is that this is 3/5 and then this is 4/5. If you need to draw out a right angle triangle, the 3, 4, 5 one, to work those out you can do. I've done enough of these to be able to do this. Right, so what's happening with this object? It's a particle of mass m, so that means I'm going to have mg going down here, and as always, put all my other forces on. I must have a reaction force as it's acting on a plane. What does it say? So it says x is equal to 2p. The particle is on the point of sliding up the plane. So when x, this original force, is 2p here, this is just about to slide up the plane, which means that friction has to be opposing motion. So I don't mind putting it there, but I've got to have it going in that direction. As always, once I've put all my forces on, I'm going to resolve, in this case, parallel and perpendicular to the plane. So we've got, in this situation, that's alpha again, which means if I put my arrows on, this is mg cos alpha, and this is mg sine alpha. So as soon as I've got all my forces acting on there, then I tend to resolve perpendicular to the plane, do F equals mu r, and resolve parallel to the plane. So if I'm resolving perpendicular to the plane, I've just got those two there. So let's just tell the examiner what I'm doing. So resolve perpendicular to the plane. And if I do that, F equals ma, or rather R is equal to mg cos alpha, which means R is equal to 4/5 of mg there. As soon as I've done that, I'm going to do F equals mu R. So that's going to give me F is equal to 4/5 mg times by mu. Then resolve parallel to the plane. So go back and just have a quick look. Obviously, can't leave these on the diagram, but those are the forces I've got. The F and the mg sine are acting against the 2p there. So I'm going to say F equals ma, which is F plus mg sine alpha is equal to 2p, sorry, handwriting, is equal to 2p. Put in what I know, so 4/5 mg mu plus sine alpha is 3/5, so 3/5 mg. Handwriting absolutely dreadful there, I'll try and tidy it up. Is equal to 2p. Okay, go back to the question. Question says, when x is p, the particle is on the point of sliding down the plane. So what I've now got to do is to basically give myself this diagram again. I'm going to use the wonders of the iPad. Obviously, I'm aware of the fact that you can't quite do it like this, but we've got that situation again, but this time we've got a force of P there, and because it's going the other way, then friction is going to be going up the plane. But everything else is the same, okay? So what I can do in this situation is to resolve parallel to the plane again. Yeah, everything with all the other stuff has stayed the same. This time I'm going to get that these two are going in the same direction and are going against that one there. So save myself a little bit of time here in terms of, let's just still say F equals MA. So F equals MA, P plus F equals MG sine alpha. So P plus 4/5 mg mu is equal to 3/5 mg. And now we've got these two equations that I can try and get mu equals. Okay, so I'm going to try and do that with those two. Well, let's just get rid of those two highlighters. So I've got 4/5 mg mu plus 3/5 mg equals 2p, and I've got p plus 4/5 mg mu is equal to 3/5 of mg. Even though I've got them highlighted, I always like to write them down underneath each other, and then all I can do is I can take the P from this one, 3/5 mg minus 4 mg mu, and put it into that one there. Okay, so if I do that, I'm going to get this bit again is equal to 2 lots of P, which is this one minus this one. 3/5 mg minus 4/5 mg mu. Cancel out all the mg's. Okay, they can all just cancel. Oops. What am I left with then? 4/5 mu plus 3/5 is equal to 2 lots of this bit, so that's 6/5. 2 lots of the other bit, so that's 8 mu over 5, and then just rearrange. Take the mu's over to the other side, so 12 mu over 5 is going to be equal to 3 over 5. I've just taken that over there and that over there. And then that gives me mu working out to be equal to whatever it works out to be. In this case, mu works out to be equal to 1/4. Okay, hopefully that makes sense.